Hello, this is Phys103. This is on nuclear physics, and here we are going to work out examples on carbon dating. So for A, we have to determine the number of carbon-14 atoms in 1 gram of carbon-12. So next, we will find the decay constant of the carbon-14 atoms. And last, we will find the initial activity of 1 gram of carbon-14. So A, we are to determine number of carbon-14 in 1 gram. So let's write number of carbon-14 atoms in 1 gram. So 1 gram of carbon-12 is equal to 1/12 moles. And for 1 mole of carbon-12 for 1 gram of carbon-12 we have for 1 mole we have 6.02 times 10 to the 23 atoms in 1 mole of carbon-12. And then for every 8.3 times 10 to the 11 atoms of carbon-12, we find that there is 1 atom of carbon-14. So this cancels out. So we can solve for the number of carbon-14 atoms. So performing this calculation, we will get that this is equal to 6 times 10 to the 10 atoms. So say you have a sample of carbon-12 with some carbon-14 in it, 1 gram of sample. So in 6.02 times 10 to the 23 atoms of carbon-12, you can find that there is 1 carbon-14 atom in that 1 gram. So next we will find the decay constant for carbon-14. So solving for the decay constant, we have lambda equals natural log of 2 over the half-life. So we have here 0.693 over 1 year is equal to not 1 year. The half-life is half-life is in seconds. This is equal to 1.81 times 10 to the 11. So let's go back a bit. Where did I put it? So it's 5,730 years. So this is 1.81 times 10 to the 11 seconds. So divided by 1.81. So the decay constant is 3.83 times 10 to the minus 12 per second. And last, we have to find the initial activity of a 1 gram of, this should be carbon 12. So in 1 gram, let's recap a bit. In 1 gram of carbon 12, you have 6.0 times 10 to the 10 atoms of carbon 14. So we will find the initial activity not of carbon 12 but the initial activity of the amount of carbon 14 atoms in that 1 gram of carbon 12. So just to clarify, carbon 12 is not radioactive. What's radioactive is carbon 14, and in that carbon 12 we have this amount of carbon 14. So yeah, let's find the initial activity of carbon 14 in that 1 gram of carbon 12. So we have our equation. A naught equals sorry, not this equation. We have D equals lambda n of t. Or we also can write this as A naught equals proportional to equal to some proportionally constant times the initial number of carbon 14 atoms. So A naught equals our decay constant is 3.83 times 10 to the minus 12 per second times the initial amount of carbon 14 atoms, 6.0 times 10 to the 10 . So we will find that this is about 0.23 per second. Or we can also write this as 0.23 becquerels, because atoms per second can also mean decay, or number of decayed atoms per second. So we have an initial activity in 1 gram. In 1 gram, and suppose that we have obtained an artifact and we measured its current activity. So comparing this initial activity and the current activity, we can measure the time interval between those two events. So at this point, when a living being is dead, it will not take in more carbon and its carbon 14 will decay. And after a certain period of time, we can measure that its current activity will be lower, and we can calculate the amount of time in between them. So that is carbon dating.